All right. Advent of Code day 12. Wow, has it already been... We've already done 11 of these. That's kind of neat. We're not quite halfway done. 2/5 of the way. Well, after today, we'll be 2/5 of the way. Okay, cool. Let's just kick it off. Day 12, rain risk. Your ferry made decent progress towards the island. Good. One thing I have noticed is that my computer seems like it's taking off. What is this? OBS is taking a lot of energy. Well, that's normal. And I've got a node process that didn't die. I'm just going to kill it. It's probably one of those ones from yesterday. Hopefully that'll pull things under control. Okay. But the storm came in faster than anyone expected. The ferry needs to take evasive action. Okay. Unfortunately, the ship's navigation computer seems to be malfunctioning. Rather than giving a route directly to safety, it produced extrememly circuitous instructions. That's a great word. Okay. I feel like every day I'm just like, who writes these? It's great. Okay, when the captain uses the PA system to ask if anyone can help, you quickly volunteer. Can you imagine being on a plane and be like, quick, is there a software engine? Can anyone here build websites? It's my time to shine. Okay. Take that, doctors. The navigation instructions, your puzzle input, consists of a sequence of single character actions paired with their input values. After staring at them for a few minutes, you work out what they probably mean. Cardinal directions. Left, right, forward. Okay. That's an interesting mix. So they're giving us the cardinal directions, like move north and also turn left and right by a number of degrees. That's weird. And move forward by a given value in the direction the ship is currently facing. It's a weird mix, right? Just to give someone specific cardinal values, but also give them left and right. That's weird. All right, so the cardinal values in forward mean move, and then the left and right mean turn. Let's see if this makes sense. I'm sure it will. The ship starts by facing east. Only the left and right actions change the direction the ship is facing. That is, if the ship is facing east, and the next instruction is N10, the ship would move north by 10 units, but would still move east if the following action were F. So I guess the ship can go sideways? That's pretty cool. Okay, for example, forward 10 goes east 10, north 3 goes north 3, forward 7 goes east. So forward is basically just an alias, I guess, for whatever the direction is. And R means right 90. Okay, so that would make the direction northeast, south. And then forward 11. Okay, cool, we'll go south 11. So, okay, cause it to turn right by 90 degrees face south. It remains east 17, north 3. Okay, so an F11 would move the ship 11 units south to east 17, south 8. At the end of the instructions, the ship's Manhattan distance, the sum of the absolute values of its east and west position. Manhattan distance is always fun. From its starting position is 17 plus 8. Manhattan distance. It's like a New York block. All right. Cool. Okay, I think I got a pretty good handle on this. He says confidently, as he probably does the wrong thing. Well, let's make directories and put stuff in anyway. All right. We'll see if we can get a better understanding of what it is that they're asking for as we're sort of like working through how we're going to solve this. Okay, for example, and this is going to be our test input. Input, there we go. And we'll indent that. These instructions would be as follows, plain. Okay, cool. So as usual, we're gonna have our defs, we're gonna have our tests, and we're gonna have a section where we just run the thing and get the answer. Cool, so we've got our test input, and what are we gonna be asserting? We're gonna be asserting eventually, let's write this stuff down right now, the Manhattan distance. So let's write down our assertions and just comment them out for right now. So the starting position is east 17, south 8. So if we model the positions as integers, east would be positive because it's right, at least that's how I feel. South would be negative because it's down. Again, sort of like on the, I don't know which way you see this, but on the grid, up and to the right are usually positive. So this would be xy would be 17 and -8, and the Manhattan distance of that is when you basically just add them together, add their absolute values together to make 25. So cool, so this is what we want, x equals 17 and so usually if we're imagining these things on a grid, if we're drawing them on a grid and we're doing like an array of arrays, I find it much more natural to have it be yx. So this is how I'm going to represent it here, just because then if you have like row, 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 whoops, the first one would be y, would be down, and then the next one would be x, right? So if we've got, so for instance, if we're trying to show a position, like this position right here, how you would say that is an offset of 1 in the y direction, so -1, or I guess that would be +1, and then plus 17. This is the opposite of what we're doing, how we've talked about notating this though, because that would make the positive direction south rather than north. So I'm not sure I want to do this. Let's just since we're not asked to draw it, since we're not asked to parse any maps, let's just leave it as north being positive, because we can go in the other direction, and south being negative, and then east being positive and west being negative. So, okay, these are in the def section, these should be down here. So these are the things that we're asserting. This is gonna be Manhattan distance. So we want to assert 25 is Manhattan distance of input, and we'll probably parse input. And we're going to so that's going to be a run parse input, and then we're going to have assert 1817, or -817 is the output of run, so that's going to be their final position. Okay, cool. So I'm assuming that this is where we're going to be. Log equals console. We'll see how close to this we get, and acquire assert. All right. So with that in mind, let's make our methods. The first thing that we need to do is we need to parse the input. So we've got this input, and we need to turn it into its base components, which is a command, and then an argument. So parse input is going to take a wall of text, and what we're going to do is the usual thing, text dot split on a new line, and then what we're going to do is we're going to map each line, and we're going to turn it into command argument. Okay. There we go. One day I will learn how to type. Cool. So we're going to do, this is the first match in a regex match is always the string that was matched, which I guess would be nice, except I almost never want that. So it's really annoying. So I just stuff it into this underscore variable. I think you'll find that quite often, is that people throw away variables as an underscore. Anyway, so we've got that, we've got the command, and then we've got the arg equals, and then we're going to do line match, match, and then we're going to match on this regex. So this regex we could pull out into its own constant, which is a great idea if you want to reuse the regex, because otherwise this will get built as it's run. But since we're only parsing the input like a handful of times over the course of this program, maybe like once theoretically, we can just have it in line. I find it reads a lot nicer. So we're gonna have a word character followed by one or more decimal characters, and each one of these is going to be a capture group. So this is absolutely gonna get some people to freak out that we're using a regex for this, when we could use basically a substring. So we could also do that. I kind of like how this reads, just personally. I guess the thing is because this pulls out, let's do the substring method today, because we do regex all the time, and also we're going to want to parse the argument as a number anyway. So yeah, let's just do that. So we'll say line, so the command will be line O, the first character of the string, and then the arg will be line 1 to the end. I forget if this is how it works. I get some confusion between Ruby and CoffeeScript this way. Oops. CoffeeScript. So let's just check it out. Okay. Yeah, okay, that's fine. That works. And we're also gonna parse float that. So we got parse input. So let's see what parse input is. Parse input of input. And we'll log that. And it's freaking out. Parse float is not defined because I have a capital L. Oh yeah, and it's giving me the last thing back. We want command arg. Okay, so F10, north 3. Is this what we're getting? F10, north 3, F7, R90, F11. Okay, cool. So we've parsed our input correctly into a series of elements. We could also we could just for fun, we could break this into like an object where we have command argument. Like we could do that, and then this might read a little bit nicer than each time we have a command and an argument. Let's do that. Why not? I see no reason why not to do this. So let's be a bit different today, instead of just having like positional arguments. So I want to keep those. Okay, cool. So the next thing that we're going to do is we're going to have a function that effectively takes an input position and follows a direction. So we're going to have a position and a heading, and the ship starts by facing east, and then we're going to apply a command to it. So let's call that navigate, because that sounds fun. It's very nautical. Navigate, engage. Okay, so we're gonna have an x and a y. So that's which was x and y again? X goes, no, x goes right and left. Yeah, I always feel like yx is better. I want to go up and down first, north, south, east, west. So we're gonna have yx, and then we're gonna have direction, and then we're going to take the direction defaults to east, and we're going to, I guess this is capital East, and we're gonna have it's also gonna take a command, or a I guess an order, and y and x are going to default to 0, I think, right? Does that make sense? Yeah, because it's from where you started. Okay, so we've got navigate, and what that's going to spit out at the end of the day is it's going to spit out these things. It's going to x, y direction. So this is what we want at the end. We're going to want x, y direction, or yx direction. This is what we want to return. Cool. So basically, the order is going to be in this format, command arg. So command arg. And so we can just structure it right here in the arguments. Why not? So the first thing we need to do, we need to determine what the command is. So we're going to switch on the command, and when the command is, let's do the right left first. So when right, when left. So what we want to do here is we want to change the direction by a certain amount. So we're going to have our cardinal points, which is north, south, east, west, split on nothing, or that's terrible, north, east, south, west, like that. And when we turn right by 90 degrees, what we actually want to do is we want to shift right by 1. So arg divided by 90. So we want to get the number of degrees to go by 1, and we're gonna want to go dirs equals, okay. And what we're gonna want to do is we're gonna want to set dir equal to dirs. This is what should we call this? I guess we can just figure that out there. So we want to go so we have to figure out where we are. So we want the index of dir, index of, and that would be dirs dot index of dir, plus these, and we want to mod the whole thing. Okay, this is getting messy. I want to mod the whole thing by 4, or by 3, or no, we want to mod the whole thing by 4. Hold on, it's getting confusing. Okay, so let's get the current index. Index equals, okay, so we got, this is the current index. So say we're already facing east, so this would give us 1. And we want to turn 90. So we'll change degrees, or I don't know. The delta index would be arg divided by 90. So 9 degrees would be 1. And so now what we want to do is we want to go index, so the new index would be the index plus the delta index, so 1 plus 1. And in case this became 4, which would be 0. We wanna mod 4, which is what so we can wrap around. Okay, and so this is what we're gonna do. So that's right, and then left is gonna be the same thing, except we're gonna be subtracting that, and then right 180 is the other one. Would be the equivalent of left 180. So subtract 2 plus 2. Okay, so that's left and right. We can test that in a sec. When north, south, east, west. All right, north, east, south, west. Let's do it in a clock. So north, we're just going to move x by a positive amount. So we are going to say x plus equals to arg. East, it's going to be y. South, I'm going to subtract by an amount. And then west, we're going to subtract by an amount. And there was one more. There was also forward. So forward is when forward. So what we could do here is we could look up, we could make another table like this, and we could look up the direction, or we could just call navigate again. So let's just do that. So let's call navigate with y, x, and the direction, instead of passing through the direction, what we'll do is we'll call dir, which is, I guess, the direction we're already facing. Right. So we'll just call navigate again with dir, and the command, or I guess with the command would be dir as well, right? Because we're saying go in that direction by arg. So let's, whoops. And that might be a fun shortcut. And this is going to give us yx dir, whoops. Okay. And then at the end of this, we're going to return yx dir. Okay, so here we've got our navigate. I guess what we could do, we could just make this dirs doesn't, dirs. We can make this just a top level const, because I mean these cardinal directions don't change. Okay, so before we get too far into this, we should probably start testing this. So let's assert the first thing. If we go forward 10, so let's log, what do we call this? Navigate 0, 0. I guess what we could do is, since command args is the only thing that changes, I mean, we can just put that first, and we'll have the rest of these arguments just be defaults. That'll make our lives easier. So everywhere we call navigate, aka right here, we can just flip those. Okay, and that way we can just navigate the direction, which was forward, or what's the first direction? Yeah, forward 10. So let's log that and see what we get back. What we see is 0, 0 east. So that's what we're getting back. That's not what we were hoping for. What we were hoping for is that forward would call, well, let's log the arguments here. Log arguments. So I'm hoping, what we're hoping for is we're hoping that it will go forward. Forward we'll call navigate with east, and then we'll see it called twice. So we're not going to log parse input anymore. Okay, so argument, oh, right. I guess we should put this in. This is command F. And then this is argument 10. Let's call it with the right arguments. Okay, cool. So it calls forward, and then that calls east with 10. And by default, y, x, and dir are correct. So it's not giving us the right answer. Which is upsetting to me. So why is that? And this is what it should be returning. Okay. So let's log this at the end as well. So it's still going 0 east. So when east, so this should have triggered y plus equals arg. And let's see if it's doing that. Log hi. It is not triggering this. So it should be switching on the command, and the command should be east, and it should be logging high. So let's log command. Forward and then undefined. Oh, that's because navigate dir arg. Whoops. Guess I should type better. Okay, so this is doing stuff, but it definitely crashed. So let's see what happened. So it went in. Oh no, we did. Oh, I see. We want it, the direction to be the argument, but with the label command. Okay. Cool. So that should fix that, and it does. Okay, so that takes us forward 10 or east 10, and then x, y. So yx. Okay, that takes us east. Perfect. So neat. You can remove some of these logs now. Log high, log the output. Okay, so it is recursively calling navigate with the direction as the command, because these are named arguments, or basically it's kind of a named argument. It's an object. And then we've got y, x, and direction. Okay. So let's then do N3. And see if, so this would take us east 10 units. Okay. Well, let's do R90 and see if it changes south. See if it's going south now. R90. So now it is, yeah, so it starts at 0, 0 and it's going south. Okay. I feel like this is probably safe enough for us to make an attempt. So we've got parse input, we've got a single navigate call. And so now what we want to do is we want to navigate until we're out of inputs. So for what are we getting here? Parse input, order in. Okay, so we're gonna have what's that? Autopilot, auto navigate. Engage. Okay. And this is going to be a list of orders, and for order in orders, what we're going to do is we're going to navigate. I guess what we'll need is we'll need a start x or a start y, x, and direction. Okay, so we've got our yx direction, and we've got our list of orders, and the orders are just going to be an array of command args. So for order and orders, what we're going to do is we are going to navigate order yx and then dir, and then what we're going to do is we're going to update yx dir. And then at the end, we're going to return our y_xter. Is that it? Is that all we do for order and orders? We update the things with the order. All right, let's give it a try. So let's log engage. Oh, we called it run down here. Engage. Let's make our first assertion and see if it just passes. It does not. Okay, cool. So false equals true. So I guess what we should do, oh, right, this should be assert 817 and a direction. I guess we'll log this to see what direction we get, because that'll be easier. So south. And it's coming back 17.8. Yeah, so 17, comma, -8. And what do we want? South. And this is the other annoying thing, is like, again with JavaScript, is this this is not going to be the equivalent of the array that we get back. Like, it's going to be equivalent, it's not going to be the same. So this is one of those times when we need whatchamacallit from Lodash is equal. Whoop. Nope. There you go. Is equal or underscore. I don't know why. I'm used to underscore, so I just use underscore. Assert is equal that. Actually, I think we might be able to use just assert is equal. I wonder if we can do that. Anyway, it's not having is equal is not a function. Is require underscore. So that works. I wonder if assert equal works. It does not. Because they're not the same. They're not exactly the same. Okay, so we're going to stick with assert is equal. And then we can assert. So, and then we need the Manhattan distance. We need Manhattan distance. And let's just do it like with camel case, because that's how we've been doing stuff. Equals. And this is a very simple calculation. It's just math.abs y plus math.abs x. And just put some defaults, bas, math.bas. Cool. So that assertion fails for some reason. Manhattan distance, oh right, because it's going to be the, and then we're going to have the oh right, and it's going to be this, but it's going to be exploded. And I gotta get rid of that. There we go. Okay, so this is just going to take the first two arguments, which is these distances, and it's going to ignore the direction. Cool. Okay, so we've got our assertions and they're working. So now it's time to run. We're going to log and parse input, and input is going to be require whatever we get out of this file, input, and that is going to be our puzzle input. Cool. Grab that. New file, input.coffee. Input.coffee. Module.exports. Export. There we go. Bam. All right, I see we got some 270, 180. I think we're probably good. Let's find out. 2104. Wait a second. Wasn't that the answer from yesterday? Yeah, wait a second. What is going on here? That's the Manhattan distance. Okay, I mean, let's give it a shot. 2104. Is it? That's not the right answer. Yeah, wait a second. That's super weird. Okay, so what does it say? That's not the right answer. Your answer is too high. If you're stuck. Oh, Kitten Flap says, Bass, thank you for warning me. Appreciate it. I'm gonna have to keep a better better eye on the chat. So that's interesting. So the Manhattan distance. So let's see what engage parse input gives us. So this is where we ended up. We ended up here facing south. I mean, okay. And let's maybe in engage, what we can do is we can show that we can log order and just get a sense for what we're doing. I see some undefineds in here. That's not good. Okay, well, so clearly going east gave us undefined. So it looks like it's our directional system that's fucking up. Okay, so if we go left by 90, we're getting undefined when we were north. So what happens if you have a negative number in mod 4? Well, let's find out. Maybe that's what it is. Oops, copy script. Find this is an easy way to get an eval. So what's so let's say 5 mod 4. So alert, this should give us 1 or run. Good. And then what about negative 5 mod 4? Let's find out. Negative 1. So we want to abs that. Math.abs. Math, not math.bas. Thank you, Kitten Flaps. Appreciate it. Okay, so this is giving us a different answer, which is good, and we're not seeing any undefineds. So, all right. Well, let's give that a try. And let's turn off this. Let's turn off this verbose log. Okay, so 2284 is what we ended up with. Let's give that a shot. Turn to day 12. Submit. That's not the right answer either. Okay. Your answer is too. Oh, and we should have known it was too high because we should have known it was too high because the previous answer was 21 something and it was too high. And oh, Pavel has joined. Even math has abs. Yeah, I know. Wish I was math. All right, so we got. So let's put this logging back and take a look at what it's doing. So 1945, 339. Okay, so let's step through a couple of these. So we go forward 10, then we go north 3, then we go forward 7. Okay, this is all looking fine. Right 90, east is going to south. Forward 11, so now we're pointing south. So going down 11, okay. Forward 10. Oh, okay, so this is interesting. Look at this. We flipped from south to east for some reason. And that shouldn't have happened. So that's clearly wrong. So why did we flip from south to east? We went forward 11, and that took us negative, and we're going south. So our direction would have been south at that point. And maybe and we did a forward. So these forwards, so forward seems to be resetting the direction. So, okay, so yeah, going forward. So this is resetting y-axis direction. So maybe maybe this direction isn't correct. Maybe what we should be doing is we should be logging this, and then we can see if that differs, if that makes sense. So let's take a look. So this should have printed out, theoretically, it should have printed out the same thing twice. Effectively, except it's doing it as arguments apparently. Where is it? Oh yeah, order. Yeah, we don't need that. So we can just, whoops. There we go. Okay. And it's not printing out necessarily the same thing twice. So the command is north. Interesting. Okay. So look at this. It's saying the command is east, and is east, direction is east. And then engage, but the direction I don't think should have been east at that point. And is it because engage, order, direction, and this should be returning XY direction. Oh, no, but this should be updating the direction. So yeah, why is it changing direction? So that's the real question. Okay, so where was this? It went forward. So at some point it goes right and turns south, and then it goes forward, arguments 11. Okay, and then it somehow is going east again. And this seems to get reset. This gets reset for some reason. Why is that being reset? Are we calling navigate? That's super weird. It gets reset a lot, east 99. So that looks wrong too. Do we have some weird, oh no, east 99 is fine. Yeah, that's super strange that it's getting reset, and I can't quite figure out why it's being reset. So we should have, so these are the arguments that we're sending to navigate that we're seeing here. And you know what, I'm gonna say from engage. There we go. And then I'm gonna log up here. I'm gonna say this is from navigate, just so I know which one is which. Okay, so back to the top. So navigate. We should, you know, let's call these before we make the call as well, so that way we can compare what we're putting in. So undefined east. So I guess y equals, or the first time we call this, it should be, I mean, oh, that's interesting. Look at this. We're calling undefined east in again. Oh, this is right. Okay, so this is it's not necessarily resetting. It's these assertions that are running. Oh, okay. 2284. Okay, so maybe this was a false hearing. Maybe we're not resetting at all. Okay, so we got forward 99. So let's take out some of these logs. Let's take out this log, because I think we were following a false, like a red herring there. All right, so we're going forward 99, and our direction is east, so that's y. Is that right? And then we go left 180, which should change us to west, and that calls west. Oh, look at that. Left 180. So maybe this is the problem. Left -2. So this is not updating us to the correct thing. So when we call left 180, this should give us the index of E, so 1, and then it should give us 2, so it'd be minus 2, so math abs 1, oh, math abs, maybe we shouldn't be math absing here, but maybe we're math absing the wrong, I think we're math absing in the wrong place. We should be math absing of the answer of this. Okay, so let's see if, no, it's still giving us 2284, so I don't think that's going to be it. But at least we switched to west, which is correct. Okay, so we're going forward 99, and then we go left 180, which should flip us from east to west. So then we say, okay, go west 1, but we're not, this isn't updating the direction. So that's very strange. It should be updating the direction. So this gives us command dir, but then when we pass dir as an argument, okay, so we go command west 1. These are commands in the input. Let's take a look. Yeah, west 1, west 2. Oh, but our direction isn't changing when we go left. Why is that? So it should be changing, and it's not changing. Okay, so let's log dir. So every time we went left, we should log the new direction now. So we go left 180, and we were east, and we should be west now. So let's log this as well. And this should be, it's giving us a 1. Okay, that's interesting. So okay, so arg, it's 180. Okay, so let's log everything. Let's log index, deindex, dir, and then that, and then, oh, this is before it updates its new dir. And then we want to log the new dir. Okay. All the way up to the top. All right, so 1, it's got an index of 1, it's got an offset of 2. So 1 minus 2, so that's the offset of 1 minus 2 should give us minus 1. Mod 4, minus 1 mod 4. So maybe we do want minus 1s to be 1 mod 4. Oh. Maybe we want, actually not mod 4, maybe we want 4, we want the math abs of 4 minus, no, we don't want that. This is crazy. Yeah, let's stop and think about it for a second. Okay, so we've got our cardinal directions. Okay, so we've got north, east, south, west. Okay, and we start here with an index of 1. So this is 0, 1, 2, 3. So we start here. And then what we want to do is we want to figure out how far away we should be. And that is 180 degrees. So that would be 2. So we want to be 2 away, but we're going to subtract 2, which would take us to here. So that should go from east to west. And that's what we're doing here. We're subtracting 2, but when you subtract 2, that goes to -1, and we want -1. We want maybe 4 plus to accommodate for 4 plus -1. Whoops. Whoops. I think this is probably what we want. Okay, so let's try that. Oh yeah, it's angry about this because that's not actual code. So let's see if that fixes it. So it flips from east to west. Okay, yeah. So this is, I think this is what we want. Okay. So we kill that log, and then we'll put that up here. But of course, this is going to be 4 plus. I don't think it'll make a difference here, but we will find out. So this gives us 420 as a Manhattan distance. So easiest way for us to check would be to put that in and see if that is the correct answer. Where are we? 420. Turn to day 12. 420. That's the right answer. Cool. We're 1 gold star closer to saving our vacation. Nice. So that was an annoying misstep. And how did we screw that up? So the question is, I mean, not that we shouldn't have screwed that up, but like, let's try to figure out how we got into this case. So the first thing is we started with write, which is a pretty simple case. We don't even need this, I don't think, for write. 420, we don't. And the reason we don't need this is because if you take any position in this array and you add to it, you're going to get a number that is greater than 0, because we're adding things together. Down here, where we're going in the other direction, we could conceivably get lower than 0 because we'd already done and tested right. I think I just assumed like, oh, left is the same thing except we subtract, and I never considered the fact that we might end up getting a negative value and that should wrap around from the left, or from the right rather. So I think what it was doing is it was wrapping around from, it was going negative and then it was wrapping from the left. It was bouncing off the left side, and we didn't want that. So effectively what we did is using 4 plus is we just said, okay, so the cardinal directions are, whoops, the cardinal directions are now like that. So if you go negative, you'll end up here. Anyway, that's effectively it. Cool. So we've got these assertions. We may as well leave them in there. And then we've got 420. Don't need to log this. This is part 1. So let's move on to part 2. Cool. So part 2, we're going to have different text, and we'll leave our defs in place for now, because usually we end up reusing them. Part 2. Before you can give the destination to the captain, you realize that the actual action meanings were printed on the back of the instructions the whole time. Okay. Almost all of the actions indicate how to move a waypoint, which is relative to the ship's direction, or to the ship's position. So N means move the waypoint north by the given value. South, east, west. Left means to rotate the waypoint around the ship left, counterclockwise, the given number of degrees. So what is a waypoint then? Move forward to the waypoint.
North means move the waypoint north. So this is going to give us like effectively a target, but forward means move forward to the waypoint a number of times equal to the given value. And so right means rotate the waypoint around the ship, right? Which I think is the same as direction, but forward seems to be different because that means to move forward to the waypoint, which theoretically would have the opposite meaning to moving moving the waypoint. So okay, so here we go. The waypoint starts 10 units east and 1 unit north. So F10 moves the ship to the waypoint 10 times. A total of 100 units east and 10 units north. Leaving the ship at east 100, north 10. But now the waypoint is behind you. Or is the waypoint always relative to the ship? Okay. Before you can give the instructions, almost all of the actions indicate how to move a waypoint which is relative to the ship's position. So it's relative to the ship's current position. Okay. So F10 moves the ship. There's a waypoint 3 units north to 10 units east and 4 units north of the ship. The ship remains, okay. So this moves the waypoint relative to the ship. So the ship has a position, and then the waypoint has a position. Okay, so this is definitely more complicated. Moves the ship to the waypoint 10 times. Okay, and 3 moves the waypoint 3 units north to 10 units east and 4 units north of the ship. So the waypoint and the ship have different coordinates. The ship remains at east 100, north 10. So we're going to have ship X, ship Y, and waypoint X, waypoint Y. R90 rotates the waypoint around the ship clockwise, moving it to 4 units east and 10 units. Rotates 90 degrees, 4 units east and 10 units south of the ship. The ship remains at east 170 north. Oh, the rotating the waypoint around the ship is going to be very confusing because we're going to need to translate the degrees. Like if you're like at +5, -5, and you rotate east, then you're going to be at -5 +5. And then F11 moves the ship to the waypoint 11 times. So, oh my god. Okay, after these operations, the ship's Manhattan distance from the starting position is 286. Okay, so this looks like it's got significantly more complicated. So we're going to want to keep this input because this is okay. So part 2. So definitely got a lot more complicated. All right. And we're gonna, this is our previous input. Using the same instructions as above. We'll just grab this and put it in here. Okay, so navigate, we're going to get the same commands, and we're going to have, so we have two what the commands mean has changed. And we're also going to be tracking two sets of variables. We're going to be tracking waypoint X, waypoint Y, and then ship X, ship Y. So let's waypoint X, waypoint Y equals, and what do they say? It's like, it starts, I mean, we'll just start these at 0, and then we'll fix it in, and waypoint starts east, I think. What does it say? Okay. The waypoint starts at 10 units east, 1 unit north. So that's waypoint Y, waypoint X. Let's do it the same direction. So 10 units east and 1 unit north. Okay. So then we've got, maybe we should put these at the end after direction. Okay. So the ship will start at 0, 0 facing east. And then the waypoint, or maybe the waypoint, maybe we don't care about direction anymore, because the direction is now about where the waypoint is relative to, yeah, okay, so we no longer care about direction. So that's going to be waypoint Y, waypoint X. So these are the only things we care about now. Waypoints, and yeah, okay. All right, cool. So right and left no longer do these things. And then north, east, south, west, these still exist and still do the same thing that we want, right? Moves the waypoint 3 units north. So these move the waypoint. Cool. And then forward means move the ship to the waypoint a number of times equal to the given value. So then forward, rather than calling navigate again, I think what we'll do is forward would say, so we want to do arg times. So I mean, we could just loop until arg equals 0. Yeah, we could do until arg is 0. And then arg, or I guess we could do for I in arg, or for step in 0 up into not including arg. Oops. Yeah, and we don't need to do this. We will say y plus equals and then x, waypoint x. And I mean, this makes no sense. Just do times arg. Arg. I don't know why I'm trying to do this in a loop. We can just multiply it. So forward is going to move the ship y and x by the waypoint y and x. So the great thing that we'll need to do now, like the difficult thing, will be we're going to have to translate the waypoint when we go right and left. And this is probably going to be the very difficult thing. So right now we've got so we got this field of things. Okay, we are right in the middle here. We've got this waypoint that is yx. So it's going to be, this is our waypoint right here. So this is going to be, you know, +2, plus 3. So, okay, so this is currently going to be, so y equals 2, x equals 3. And what we want to do is we want to, if we rotate this 90 degrees, what we want to do is we want to put this w down here where it becomes x to y negative 3. So we're sort of like, we're flipping it. Now, how do we express that? How do we express that as programming? And then if we do it again, it would be, what would be like over here or maybe over there. Okay, so how do we express this as a rule? So I guess whenever we rotate, one of them will flip. So if there's, so then it becomes -2, -3, and then it becomes 3 or -2, -3. And that's how that would work. Okay, so if they're both positive, so we can determine the direction by their positivity. So if y is positive, y is negative. If y is negative, then y becomes positive. So that one of them always flips. So either y flips and then doesn't flip, and then x flips and then doesn't flip. So if they're the same, then y flips. And if they're not the same, so if they're both above 0, then y flips, and if they're not above 0, or if they're not the same, then x flips signs. And then they either flip signs or they change positions. Is that right? Or do they always change positions? So 2 3 3 2 2 3. Oh, and then this is 2 3. I think I might have this wrong. This might actually be 3 2, like this, except 3 2. So they always flip. I don't know if that's correct, but I'm going to assume it's correct. I'm pretty sure. I'm reasonably sure that this is how that works. So let's just double check here. Right means rotate the waypoint around the ship right clockwise by the given number of degrees. Okay, because this starts at +2 +3 and then becomes -2 +3. Oh, so this is actually wrong. -2 +3. So this flips that, and then if we rotate it, yeah, what does rotating it look like? Rotating it just changes the sign. It never changes direction. -2 -3, and then +2 -3. I think that's correct. It always changes the direction, or it always changes the sign, but it wouldn't change the value. Or maybe it would, or maybe yeah. What does a rotate mean? Let's try to think about a less ambiguous one, where they're not sort of similar. Okay, so in this case we've got +2 +1, and then when we rotate it, it would actually go, yeah, +2 -1. So we absolutely do flip it, because rotating this would make it plus. This is kind of a crappy map too, because the line height is so much different. So it would go +2 -1. So it would go to here. Yeah, so it absolutely does change positions. Okay, so +2 -1 becomes minus, or +2 +1 becomes -1. Okay. So first we need to figure out which quadrant it's in, and then we do need to flip these, and then flipping it again would bring it down to here, which would be +2 or -1 +2, or plus -1 -2, -2 -1 -2 -1. So x is -1. And then this one would be so 1 and 2. So that would put it in this quadrant where it would be y is +1 and then x is -2. So we are, yeah, okay, so we are flipping the values. Okay, so we flip the values, and then we also have to change the quadrant. So interesting. How are we going to, is there a trick for rotating quadrants? I guess the quadrants, what we can do is we can determine what quadrant we're in based on the positivity of x and y. Maybe there's a thing for this. Maybe there's an easy way of doing this. Rotate quadrant. Yeah, I don't even know how to Google that. Also, I don't know. I'm not above using libraries if like you kind of understand what it's doing, but I feel like in this case this is sort of the challenge is to figure out what it's doing. So let's try to implement it ourselves, even though it will probably be very difficult. Okay, so rotating the waypoint. Okay, so we've got these basic states, and I'm just going to put them down here closer to where we're going to be writing this. So what we could do is we could just switch on. We could switch on the current waypoint x and y, or we could get a quadrant. So we could have like quadrant like 0, 1, 2, 3. So we could put these into, we could make a function that spits out a quadrant and then change what we do depending on what quadrant we're in. It's probably not the cleverest way to do it, but let's do this. Quadrant equals, and we're gonna have an x and a y, or a y and an x, because we're doing everything yx. So if y above, or I guess, oh yeah, what about 0? What quadrant are you in if one of them is 0? I guess it doesn't matter, because if you flip 0, like the sign positive and negative 0, it doesn't really matter. So let's just stick with above or equal to 0. If x is above or equal to 0, then we're going to pass out quadrant northeast. We'll just name them so far. So northeast. Whoops. Okay. Else. So x is going to be negative in this case. Northwest. And then else
if, so these are going to be south, southeast, southwest. So quadrant for y and x, and I guess y equals 0, whoops, x equals 0. So, okay, so we want the quadrant for waypoint y and waypoint x. So we're going to switch on that, switch on the quadrant for waypoint y and waypoint x. Switch, and when, okay, when northeast. So when we're northeast, what we want to do is we want to, oh, these are right, these quadrants are we're gonna need to do a similar thing that we were doing here, is figure out which quadrant we're going to, or we could just do, we could transform them in a loop, we could rotate them in a loop based on that. So so times equals, right, we're gonna have to have the direction index. So we are gonna need that, and we're gonna need the times, it's gonna be that. Okay, so and this is gonna need to know our current quadrant. So actually the times is just going to be math abs of r divided by 90, right? So it's going to be 1, 2, but the direction matters as well. So we can't actually say that. So times equals, so we'll go 0 up to times, and 0 or 0 down to times. Or maybe we'll have to do something based on the direction. I'm probably making this way too complicated. But whatever. Okay, so switch quadrant. So yeah, so if we turn right, I guess we know we're going right this time. So times is always going to be positive. Okay, so times is going to be that. So when we're in the northeast, we're going to need a function to rotate this number of times. So when northeast, what we do, so we're here, we want to flip the positions, and we want to make y negative. So wx, wy equals we should do wy, wx equals wx, wy, and then -1 times wy, right? Because we want the resulting y actually to be, so this is going to be 1 rotation. And then the next, so this is a northeast rotation. So I guess the other thing we could do is we could actually we could assume, I mean, we could call this, instead of calling this times and doing this a certain number of times, I guess what we really want to do is we just want to rotate the things a certain number of times. So let's make a rotate function. That's what we want to do. Rotate. Okay, equals, so wy, wx, waypoint y and x, and
we're going to, and then we're going to have a number of times that we're going to do times. Times, we can default that to 1. So we're going to switch on the quadrant. Or wait, we're going to rotate, hold on. Yeah, it's getting fuzzy here. So what are we doing when we're rotating? What we're doing is we're taking a pair of numbers in, and we're applying this pattern to them, where we're flipping the sign and flipping the values. So we always flip the value, and then we flip one of the signs based on what quadrant they're in. So we are always going to do this. And then based on the quadrant, what we're going to do is we're going to change the sign. So, right. So when northeast, except this is going to be x, y, or yx rather. This is going to be our return yx. And then we're going to come back with yx. Okay. And then based on the quadrant that they're in this case, we're going to say y equals, or can we times equals? And when southeast, then we're going to do x times equals 1. And then when we go from southeast to northwest, we're going to y equals southwest. So when we started southwest, we are going to, which is down here, we're going to go y times -1, y times equals, yeah, these should all be -1, I don't know why. We're inverting. And then north, when northwest, we're going to be inverting x. So this is interesting. Okay. Cool. Can I do, is this just a Rubyism? Or can I do this? Northwest. And then northeast, southwest. I think I can probably do this. Let's find out. Copy script. Yeah, just makes the cases. Okay, cool. Okay, so we've assigned the new coordinates, and then we have altered the sign, and now we're flipping it. So that's rotate, and then we're not doing it a number of times. So I guess we can just rotate down here a number of times. So and that's, oh, that's rotating in to the right. So I guess the other question is, can we turn right rotates into left rotates? Right 180, right 90, right 90. Do they ever have like, they have 180s. Do they ever have like 270s or negative? I guess there's no negatives. Yeah, we're only ever dealing with positive numbers. So I guess a left rotate would just be a right rotate, and the argument would be 360 minus the argument. So maybe what we can do when right and left, we can do this.
And we can say if arg is left, or if command, we want to say arg equals 360 minus arg. Okay, so we're going to change the value of the argument if it's left. We'll see if that works. And then we can get rid of this left, because that might have worked. We can actually check the same thing if we're doing this here. So let's test our assumption here. Okay, so if command is left, let's do that and see if this still gives us the same answer, and it does, 420. So let's keep that. That collapses left and right into one thing for us, which is good. Okay, so we've got this times. So, and that's going to be args 90. So now we're always turning right, which is nice. For t in 0 up to not including times. That goes here. What we want to do is rotate. So we're going to have wy wx equals rotate wy wx, and I don't know why we have this times up here. Let's get rid of this times. Okay, so let's for t in times, and it can figure out the quadrant, and then and times is just this. Okay. Cool. Is this really what we're doing? Okay. So we've got arg, so we're collapsing left and right, and we've got the, I mean, we can try it and see if it gives us anything. So this is going to give us two different assertions. So we should let's find out what our new assertions are. They're up at the top here, and we should probably log a bunch of crap. So the waypoint starts 10 units east and 1 unit north relative to the ship. That is, if the ship moves, the waypoint moves with it. Okay. For example, after these operations, ship's Manhattan distance from its starting point is 214, 72, 286. So let's write these assertions down. So 214, and right. So okay, 214, 72, and 286. So let's assert that 286 is the Manhattan distance. It's gonna fail. Yeah, good. So let's find out what engage parse input log engage parse input. What is this? So this is giving us not a number. So this is giving us back 3. Oh, right, because we're still passing in directions. And this is going to be waypoint y, waypoint x, and these are both, let's assume they're both 0. Or I guess we can say that they are whatever they are supposed to be. 10 units east, 1 unit north. So waypoint y is 10, waypoint x is 1. And then we're going to get navigate is going to give us back waypoint y and waypoint x. And then that's what we're going to put back. Navigate order. Yeah. Okay. Well, so now we're getting stuff back, which is cool. So it's totally not the answer we want. but it's giving us an answer in the right shape, which is kind of cool. So, all right, let's take a look and see where we're fucking up. Okay, so the first, I think they give us some examples, right? So F10 moves the ship using the same instructions as above. F10 moves the ship to the waypoint 10 times. Okay, leaving the ship at east, north. So let's log the output every time. Okay, so log these things. So the waypoint's at 10.1, and we are now at 110. So east 100, north 10. N3 moves the waypoint 3 units north. So it's 10 units east, 4 units north. Okay, that's good so far. And the ship remains at 110. F7 moves the ship to the waypoint 7 times, so a total of 70 units east and 28 units north, leaving the ship at 170.38, which it is. Okay. R90 rotates, I'm sure this is where it fucks up. R90 rotates the waypoint around the ship clockwise 90 degrees, moving it to 4 units east and 10 units south. So 10 units south. So I think we screwed up the direction. So, because this should be -10, 4. So it should be 4, -10. Okay, so our rotate function appears to be incorrect. So the quadrant is fine. Okay, so rotate. So when we start in northeast and we rotate, we want y to go negative. So that's y and x. Is that correct? So y, and we don't want to flip x and y, do we? Oh no, we do want to flip x and y. We do want to flip x and y. And we want to make y negative. So maybe their definition of rotate and my definition of rotate are not the same. So rotates the waypoint around the ship clockwise 90 degrees, moving it to 4 units east, because what was it before? It was 4 units north, and now it's 4 units east. So 4 units north. So it used to be 10.4, now it's 4 units east. Oh, but so it was 4 units north. Now it should be 4 units east, so this should be +4, -10. So maybe we've got our multiplication stuff wrong. Maybe it's the opposite. Maybe. Does this give us the right answer? This does, yeah. So, oh no, it's 214, plus 72 = 286. So assert, and then that's it. So that's it. We just had our x and y's backwards here. Okay, so let's remove all that. Let's leave a note here about what we're doing. Collapse left and right turns by changing the degrees. Okay. And then this is going to be the number of times we're going to rotate. Okay. And this is rotate, always rotates 90 degrees. Rotates 90 degrees. Okay, cool. So let's see, and do we use DIRs anymore? DIRs? No, we don't have DIRs anymore. Okay, so that's asserting that, and it should be, what is this, 214.72? I don't know if we don't even care about this assertion anymore. So let's log the Manhattan distance and see what we get here. We should remove whatever log is in here. Log. Okay. Whoops. There we go. So this is the Manhattan distance that we get at the other end. So let's see if this is correct. It's not the right answer. Your answer is too high. Okay. So that's interesting. So our answer is too high, and that means that we're definitely doing something wrong. And what could it be? So I know it might be because we only ever turn right 90 here. So maybe if we're turning left, we're turning left by the wrong amount. So let's take a look at that. And this is what they're asking for, right? Yeah, we want to, yeah, just parse. I'm sure it is, but let's take a look. Okay, at the end, okay, figure out where the navigation instructions lead. What is the Manhattan distance between the location and the ship's starting position? Your puzzle answer was 420. Okay, we did that. And then down here, between that location and the ship's starting position. Manhattan distance always takes y and x and just multiplies them together, so that should be fine. That should be what we're getting back. So it's just wrong, and it's probably wrong. If I had to guess, it's probably wrong because of left. Mind you, this left works. Arg. So 360 minus arg. could do mod 360. We could try to. So what I'm thinking here is like maybe this gives us a different answer. It does not. Yeah, my thinking here was like, oh, well, maybe we've got a similar problem to what we had last time, which we don't. So 243 693. Yeah. Okay. So it does nothing. So right and left. And so this predisposes that a left-hand turn is the same as the opposite of the right-hand turn, which I think is reasonable, which makes sense. I'm guessing that this is where it's going wrong, just because this is what we have determined. And when north, east, south, and west, those don't change. But those move the waypoint. And then when forward, we move the ship towards the waypoint, or in the direction of the waypoint. Okay. So why is this giving us the wrong answer? I guess what we can do is we can also try to just look at log, engage. So this gives us a very big number. So we seem to be going north a lot. Let's and then log the Manhattan distance. This is going to be, that's not a Manhattan distance. What? Oh yeah, we're adding them together. 2, 3, 4. Oh, 2, 4, 3. Yeah. Okay. Yeah. So I guess maybe we should just start. Okay, so we'll remove the assert, because this assert was correct, but we're gonna have to log these things and see if something jumps out at us. Oh man, there's gonna be a lot of steps. Okay, so for order and orders, so let's log the order as well. Order. Okay. So command forward 99. Then we
turn left 180, and oh, that's not correct. So, or is it 10, 1? So that should make our new waypoint x and y -10 and -1. But it's not. So that's not good. In arg minus, so let's, so we just rotated. So maybe we've got these rotations. Oh, we're only ever rotating one. Okay, so it should be rotating twice. It should be rotating. So rotating 180 doesn't seem to be working. Okay, well, at least we know now where it's failing. So zero up to including, so this should be doing it twice. Let's log rotating. Okay, let's double check that it's rotating twice. So it's rotating twice here. Good. Maybe it would be good to log. No, that's the result. Okay, so that's fine. So it's rotating twice, and let's see what wx and wy are. Okay, so it's rotating once from 10 and 1, and that's going to 1 and -10. And then quadrant of 1 and -10 would make this north west. Oh, these are backwards, I think. So x, oh, maybe I've got y and x backwards now. So rotating, so 10 would be y, x, and then that would become y, x. So that would be southwest. So if y is greater than or equal to 0, and that would be 10 in the first one, then, and x, then it's northeast. And if y is then northwest, yeah, no, that makes sense. Why? So am I going the wrong direction? Does this actually go? So y and x are always x and y. So when northeast or southwest, we want x to flip. No, that's wrong. That's when they started in the northeast, then we do want y to flip. Oh wow, okay. So maybe this is wrong. So y, x. So let's put this back the way it was and look and see if this makes any sense. Okay, so rotating from that to that. No, we're still, I think it's, I feel like this is the way that it should be, but our idea of our quadrants is wrong. So the quadrant, or maybe we should be doing the flip before we change. Oh yeah, maybe that's what it is. Okay. So, okay, so let's get the Q here. This is the quadrant, and then we want to switch on the quadrant, and then what we want to do is we want to say, and we want to basically just return the switch. Okay. Okay. Cool. So let's see if that makes a difference. So now it still doesn't make a difference, but it does. Does this? still pass this assertion? That's the other question. It does. Okay, cool. So that was the problem with our quadrant thing, is that it seemed to be like finding the correct quadrant, but it was applying the operations in the wrong order. So okay, so we alter x and y and x, and then we flip them, and then flip the output. So when we're northeast, we want to flip y, and then we flip the directions. Northeast or southwest, we're flipping y, and then we're flipping x when it's southeast or northwest. Northwest, we flip x. Okay. So this, I think, rotate now works. So why does rotating, why is this rotation not working? So we rotate twice. So, okay, so rotating 10, 1, so that's y and x, should flip y, and then flip, right, it should flip the signs but not the values. So we want to do the flip first. Yeah, okay, so whoops, come back. No, what happened? There we go. All right, q equals, okay, so we want to flip the signs, and we want to say y x equals, okay, so I see the problem here is we're flipping signs and values at the same time. But of course this is going to be different, and then we want x and y. So when we're northeast or southwest, we actually want to flip y, but we've just assigned y to x. It's because we flipped, so this is going to flip the values. We'll flip the signs, but of the opposite thing, and then we're going to pass back y and x because that's how we roll. Okay, so is this going to give us the same answer? It does. It gives us the same answer here, and it's giving us a much saner output for Manhattan distance. So I feel like maybe we can try that. And where's log? There's log, rotating and order. So 42073. So if this is the answer, that makes sense, and that is the right answer. Okay, cool. We're one gold star closer. So cool. So what did we learn there? So rotation does two things. Rotation, it flips the sign, but it also changes the values. Your x and y values transpose, and then the resulting signs of those should be, yeah. So we want, yeah. So we're confusing things here by, I mean, we could do it maybe in line rather than trying to do this. We could say like equals minus abs of whatever. You know, this is fine. I think this is probably fine. So let's just leave some notes, and then switch Q. No, wait, we screwed something up here. Does this matter at all? Yeah, it does. So do we always want to switch? Oh, so we got a typo that gave us the right answer. That's never a good sign. Okay, no. What is this doing? So what are we switching on here? We're switching on null. Log lol log what? It's always flipping x. And it's never flipping y. So is that because x is rotating around the board? It is because x is rotating around the board. Okay, so that's interesting. So 1 times -1. So what if we do that? Okay, cool. So because this is assuming a 90-degree rotation. So basically, we're taking the values in, and we don't care about what quadrant it's in because it's always 90-degree rotation. Oh, right. Okay. So rotating. So basically, we rotate by saying x and y are flipped, and the previous y value should change signs. And that's all that is, really. So I mean, we could do instead of rotate, we could just do that, and that also gives us the same. But I like having it separated out into its own thing. Okay, so that's very interesting. So here we go. So we rotate y and x, and that's really all this is. Okay, so y becomes x, but flips sign, and x becomes the new y. And that makes sense. Okay. Cool. So may as well leave this assert in there to make sure that it runs. I feel like we kind of stumbled onto that rotation thing. This makes a lot of sense. You know, this is a lot easier than trying to figure out what quadrant we're in and apply the right transposition. We can just, like, rotating 180 degrees is just rotating 90 degrees twice, and rotating 90 degrees always follows the same rule, which is that y's value flips because you're rotating from the top right to the bottom effectively. So y's value flips and x's value becomes y, and then y's flip value becomes x. Okay. Cool. Okay. So yeah, I guess that's day 2. Let's take a look at our work and see how bad it looks. So part 1, I guess we can take a look here. Plain. So we've got parse input, which we keep the whole time. And then we've got our directions. We can just move that out onto its own line. Navigate, we're using this big switch thing. So we backported this change here where we collapsed right and left into the same thing. And this is convert a left turn into a right turn. And we should probably, oh yeah, all right, convert a left turn into a right turn. And then basically so that's in part 2. So in part 1, we get the index and we just add the number of 90s. So it would only ever be 90 degrees or 180 degrees probably at this point. well, that's not necessarily true. If you turn left 90, okay, yeah. And we don't have to do that, 4+ thing, because it's always going to be positive. And then we are recursively calling navigate with whatever the direction is. I'm passing in x, y, or yx direction. Manhattan distance, pretty straightforward. And then we've got is equal, just to make that assertion. And this still gives us 420, which is the right answer. 420. And then 420.73. It seems to be a theme. So let's take a look through here. Parse input didn't change. Rotate, this is the function that gave us way more trouble than it should have, but now makes sense. Navigate, so command arg. This is for the command and the argument. And then we've got the position of the ship, and then we've got the waypoint position. And right and left change the waypoint position. And northeast, southwest, the cardinal points change the waypoint position as well. And then forward is the only thing that changes the ship position. Okay, and then we pass back ship position, waypoint position. Engage just does it once for every order and then returns the result. In fact, I don't know that, do we need to return the result? Yeah, we do. Okay, I was thinking like the last thing in this might be the return value, but I think it would actually return the array of those. So whatever. And then Manhattan distance is that. Okay, cool. So let's commit our work, which we were in the middle of doing. We just wanted to go through it. And that is day 12. Whew, what a doozy. All right, push that. Cool. Well, I guess I'll see you again tomorrow for day 13. And hopefully I won't stumble along quite as much as I did today. It seemed to be going so well. And then it was that rotation thing, that rotating of the waypoint thing that really gave me an issue. Yeah, cool. I will see you guys tomorrow.